The goal of this tutorial is to show you how to create a simple class diagram using StarUML2. To begin, you can create a new project. I already have a new project here. It creates a project named Untitled, and that project contains in it a single folder or package called Model. And that model contains in it a single class diagram called main. I can tell it's a class diagram because over here, we see when I select it, we have a toolbox for creating elements in a class diagram, class interface, that sort of thing. So I'm going to create a simple application for banking. Maybe this would be like an online banking system, for example. So I'm going to click on the project. It's called Untitled. I'll come down here to its property sheet, and I'll change its name to banking. You have to hit enter here for that to take effect. You can also put in author, company, copyright, etc., what version it is. Here, model, so they always pick model for the name. It's kind of a stupid generic name for this. So maybe I will call this accounts. And then main, I think, is probably a good enough name for the diagram itself. So let's begin by adding a few classes here. So I can click on the class icon over here in the toolbox. And I can drop a class in here. And I'm going to name the class account. You see account has appeared over here in the accounts package. I can also create, let's create another class. Account holder. And let's create two more classes. If you're creating lots of the same element, one trick is that you can double click on the icon over here in the toolbox, and now each time you click here, it creates a new element. So let's create individual and corporation. And now, in order to stop this, turn this off, you can either click on the icon once more, or you can click on this little arrow, the little lock picture of a lock here disappears. So now when I click over here, nothing happens. Okay, so I've created 4 classes here. Over here in the model, we see the 4 classes. Again, this is where the important logical structure of the model is represented. And now let's create relationships between these classes. So the idea is that every account has an account holder, and an account holder may have one or more accounts. So relationships between objects such as has or owns or uses, usually modeled by an association here. So I'm going to click on that, and now I hold the mouse button down here and drag it over to account and let the mouse button go. And we see that I'm just going to click to get rid of that box. We see an association now has been created between the account holder class and the account class. Okay. What about the relationship between individual and account holder and corporation and account holder? Well, my thinking here is that there are 2 types of account holders, and the bank might have separate policies and procedures for dealing with these different kinds of account holders, and so they've created separate classes to represent them. Every individual is an account holder. A corporation is an account holder. Every time you hear that word is a, is an, you should think in terms of generalization. So I'm going to double click on the generalization arrow. Notice the little lock icon. And now I'm going to drag these generalization arrows. I'll click on that again to turn it off, and then I'll come back over here. Of course, we can move these around and make them pretty. Okay, so there's a basic class diagram that I've created. The code that we would expect this to generate would be that the individual class would extend or be a subclass of account holder. Corporation would extend or be a subclass of account holder. And then we would expect account holder to probably have a field relating to account, and account maybe has a field relating to account holder. More on that in a minute. Next, let's see if we can't add some detail to these elements. So I'm going to click on Account. And what I'd like to do is add some attributes and operations. There are a couple of ways to do that. I can come over here and right mouse click on Account, and here are all of the different things that I can add: template, parameter, attribute, port, operation. Some of these things kind of don't make any sense. Another way of doing it is that I can double left mouse click on this, and I get a little context menu, shortcut menu here: add attribute, add operation, and visibility, public, private, protected, and so forth. So I'm going to add an attribute, and the attribute that's important for an account would be the balance of the account. You can specify the type of the balance, and so I can do it while I'm typing it here. You type a colon, and then let's say, let's do this simply and assume that the type of an account is double. And you can also specify the initial value of this field. And over here, under visibility, let's make it private. That seems to make the most sense. And now you can see that balance colon double equals 0.0 with this little minus sign indicating that it's private. Over here, we see that balance is a child of account. This is kind of a tree-like structure of the project. And if I click on balance, you get the property sheet for balance down here. Here's its name. Stereotype doesn't have a stereotype yet. Visibility is private. If it was static, which wouldn't really make sense here, I could click on this box and notice that it's underlined. If it's a leaf, meaning it's final, I can click on this box. It might make sense, but no, I'm not going to have that now. So come back to balance. It's not a leaf. It's not final. Type goes in here, double. Multiplicity, how many balances? Well, we're just going to have one for now. Read only, ordered, unique. So these are all other more detailed properties. These are properties of the balance attribute of the account class. Now let's add some operations. So I'm going to click on Add Operation, and one of the things we'll want to be able to do is make deposits. And now type in parentheses, the parameter, close parentheses, the amount to be deposited, and then the return type. You can type in a colon after the parameter list, and then the type of the return. If the type of the return is void, then it's usually just complicates things to mention it. Let's create this plus sign. We're going to add yet another operation, withdraw, and then the type of withdraw. Okay, notice the plus sign. So these are both, plus means public. then, and again, I didn't specify the return type of withdraw, so we can infer then that it's void. You can also, if you're fussy, you can change the order of these things. You can delete these operations. Now, there are a few operations that I haven't mentioned here. For example, surely account needs a constructor. And usually an attribute such as balance here, we would expect getters and setters for that attribute. Certainly, account holders will want to be able to get their balance. I don't mention those there because I consider all of those to be administrative functions. Okay, so I only mention functions here that are really relevant to the application domain, which is banking. And you might argue, well, get balance certainly is relevant. And so if you press me on that, I'll say, okay, here's get balance. I'll mention it. And notice that the parameter list is empty, and then there's a colon here and double, meaning that it returns a double. Okay, so I think that's probably enough for account. Now, account holder, let's come over here. I'm going to click on account holder. So in this application, I'm going to assume that all account holders are either individuals or corporations. In other words, there's no such thing as just a pure account holder. So to enforce that, so I've selected that. Here's the account holder property sheet here. I'm going to click on is abstract, and you'll notice that this has now been italicized here, indicating that it's abstract. You can't instantiate an abstract class, so there won't be any such thing as an account holder. All account holders will either have to be individuals or corporations. However, we could put things in account holder. For example, if I double click here, we can add an attribute such as address. String. And here under visibility, you might want to make it protected so the address will be visible to the subclasses. We could add another attribute, ID. That's probably going to be something important. Probably everybody has to have a unique ID number of some sort. So now those will be inherited in individual and corporation. Notice that if you don't have anything to put down for an operation or an attribute, you can suppress attributes and operations to clean up your diagram. So I'm going to show you how to do that. There are two ways. I can right mouse click and then under format, down here, suppress attributes. Whoops. Let's bring those attributes back again. I do want the attributes. I want to suppress operations. Format, suppress operations. And see the operations compartment has disappeared. The reason I'm bad at this is because I'm more accustomed to using the shortcut keys. So Control-Shift-A gets rid of attributes. Control-Shift-O gets rid of operations. Control-Shift-A, O over here gets rid of them over there. So I think that that's kind of a fairly decent looking class diagram. My philosophy on class diagrams is to suppress things that just make the diagram more cluttered, more difficult to read. Next, I want to talk about the association here running between account holder and account. Associations have properties as well, so I can select that. And over here, we see the property sheet for association. By the way, some of the things that you select, you also get like a styles editor here on top of the properties editor. This allows you to do things like, alignment, and you can do other ways as well, or make the line curvy or change the color of something. So I almost never use these things. So it's kind of a shame that they insist on putting this on top of the properties sheet, which forces us to scroll down here to get at the stuff that we really care at. Now, an association could have a name. Although it's rare, that would be the name of the relationship here. And again, the name is kind of confusing in UML. Owns, for example, and what I mean here is to say that this association represents the relationship account holder X owns account Y. But notice that you can't really tell if, you could read it the other way, account Y owns account holder X, which kind of doesn't make sense. It's not exactly a symmetric relationship, but you can't really show that here. Also, it doesn't really show up in any code that would get generated as well. So specifying the name of an association is something I rarely do. And, whether it's public or private, I'll more on that in a minute. The important thing about an association are the endpoints of the association. If we look at the property sheet here, we have end1, and then a little bit further down, we have end2. End1 refers to the left-hand side, the side that references account holder. And there's all kinds of interesting information that you can specify. Multiplicity, navigability, visibility, and so forth. So all of these are kind of important relationships. You can also specify them if you click close enough to the end here. You get a little shortcut menu, not for the association, but for the endpoint of the association. Okay, so for example, the name, it says role name, so I'm going to call it holder. Here, the multiplicity. How many holders does an account have? And for simplicity, let's just assume one. There are joint bank accounts. I suppose it could have multiple holders, but let's just assume that every account just has a single holder. Okay, visibility, let's make that private. And navigability, navigable, not navigable. So here the question is, given an account object, should you be able to discover the holder of that account object? If the answer is true, then we want that to be navigable. And then qualifiers and aggregations are something we're going to skip for now and maybe for good. So here we have holder, and there's what this says is that every account is going to be owned by one holder. It'll be private, and the type will be account holder. In code, the way that this would look is when we generate a class for account, we would expect that holder would be a field of the account class. So a private field of type account holder called holder. Let's work on the other end. So I'm going to double click here. Okay, so this is how the account looks to the account holder. Now, one thing that I think is significant here is that account holder could have many accounts, savings, checking, and so forth, but they must have at least one account. So under multiplicity, I'm going to click one ... That means one or more. I'll set the visibility to protected again so the subclasses can see it. It's debatable whether this is good programming practice or not, but it makes for a more interesting tutorial. Navigability, does an account holder need to be able to navigate to the accounts he or she holds? And yes, so that should be navigable. So another little weird thing about UML is if an association is navigable at both ends, then there are no arrowheads shown. If I turned off navigability here, so let's say it's not navigable, then you get an arrowhead here, meaning that you can get from an account holder object to the owned account objects, but not vice versa. If I turn it back on, if I come over here, let's say, and click on this and say that this is not navigable, Okay, so you see that the representation of an association that's navigable on both ends, so binavigable, is the same as if it's navigable on either end, rather than just have two different arrowheads here. So that's kind of stupid, I think. Don't be tempted to fake anything. I mean, you could put in, navigations, one-way navigations going either direction here, but that's just going to confuse, any applications that might use StarUML to generate code. So what about this one or more? What is that going to look like when we generate code for account holder? Well, account holder is already going to have a protected field address of type string. It's going to have a protected field ID of type int, and it's going to have one more protected field called accounts. Now, since it's one or more, that means that accounts will have to be some kind of collection of accounts. And this opens up the debate about whether that collection should be a set of accounts or a list of accounts. And of course, there's a lot of consideration to trying to make that decision that we don't really need to worry about right now. So then in review, I think that this is a pretty good class diagram. We've covered a lot of stuff. Over here, we see that the model that we've built, let's collapse it so we can then uncollapse it later for dramatic effect. So we've got our banking application. Its main package is accounts. Accounts has 1, 2, 3, 4 accounts in it. Under accounts, we see balance attribute and then these 3 operations. Of course, there will also be administrative operations as well. We can expand that. Underneath deposit, we see AMT, which is a parameter for the deposit operation. Oh, here, this is sort of interesting. Notice that account holder is the owner of the account holder account, the owns association that runs between them, and then it's the owner of the 2 endpoints, holder and account. So again, it's this tree-like structure that StarUML uses to represent not only class diagram models, but all kinds of other models as well. So that's it for now. Thanks for listening.